A to Z Futurism, Artificial Intelligence. The branch of computer science that investigates the extent to which the mental powers of human beings can be reproduced by means of machines. AI research is a major contributor to the interdisciplinary field of cognitive science, and artificial intelligence is often associated with connectionism, symbolic AI, strong AI and weak AI. The benefits or advantages of artificial intelligence are: 1. Automation. 2. Improved customer experience. 3. Smarter decision making. 4. Research and data analysis. 5. Solves complex problems. 6. Manages repetitive tasks. 7. Reduces errors. 8. Improved business efficiency. Artificial intelligence (AI) is intelligence displayed by machines. It is said to be the opposite of natural intelligence displayed by animals, or human intelligence (HI) of humans. Foremost AI textbooks define the field as the study of intelligent agents. It is essentially any system that perceives its environment and takes actions that maximize its chance of achieving its goals. A few popular definitions used to describe machines that mimic cognitive functions that humans relate to the mind of humans. This included learning and problem solving, though these definitions are rejected by prominent AI researchers. AI applications include: 1. Advanced web search engines, i.e. Google, Bing. 2. Automated decision making and competing at the highest level in strategic game systems such as chess and Go. 3. Recommendation systems used by YouTube, Amazon and Netflix. 5. Self-driving cars, e.g. Tesla. 6. Understanding human speech, such as Siri or Alexa. 7. Modeling human problem solving. 8. Simulating the brain. As machines become increasingly capable, the AI effect is increasing, wherein the tasks believed to require intelligence are usually removed from the definition of AI. One such example is optical character recognition. This is regularly excluded, having become a routine or customary technology, therefore people consider this not AI. Artificial intelligence was founded as an academic discipline in 1956. There was optimism for this type of technology and intelligence, but it was subsequently followed by many AI winters due to a lack of funding. In the 21st century, the first decades, highly mathematical statistical machine learning has prevailed in the field of AI. This has helped solve many problems in academia. The various subfields of AI research are focused on particular goals and the utilization of specific tools. Road to general intelligence. General intelligence is said to be the ability to solve arbitrary or random problems. It is among the field's long-term goals, and to solve these problems, AI researchers have adapted and integrated a wide range of problem-solving techniques. This includes: 1. Artificial neural networks. 2. Formal logic. 3. Methods based on statistics, probability and economics. 4. Search and mathematical optimization. AI also ties into computer science, psychology, linguistics, philosophy, and many other fields. The AI field was built on the presumption that human intelligence can be precisely described and a machine can be made to simulate it. This thought therefore raises philosophical arguments about the mind, with also ethics of creating artificial ontologies and conscious minds endowed with human-like intelligence. If we study numerous utopian and dystopian science fiction with a futurology lens, our perception of AI is usually that it has enormous potential and power, yet there remains an existential risk to humanity. Church-turing thesis. Artificial beings with intelligence appeared as storytelling devices and became common in fiction. One of the first was in Mary Shelley's Frankenstein or Karel Čapek's RUR. The characters of these novels and their eventual fates raised many issues now debated in the ethics of artificial intelligence. The study of mathematical logic leads from Charles Babbage's calculating machine to Ada Lovelace's first programming of machines. The eventuality of such progress, computing from bare bones as it were, leads us to mathematician Alan Turing's theory of computation. This theory suggested that a machine, by shifting symbols as simple as 0 and 1, could simulate any conceivable act of mathematical deduction. Therefore, digital computers can simulate any process of formal reasoning. This is known as the Church-turing thesis. The Church-turing thesis, discoveries in neurobiology, information theory and cybernetics, directed researchers to contemplate the possibility of building an electronic brain or electronic mind. The primary effort that is now usually accepted as AI was McCulloch and Pitt's 1943 formal design for Turing-complete, artificial neurons. In recent years, major advancement has led to tools of AI. The tools are listed as search and optimization, logic, probabilistic methods for uncertain reasoning, classifiers and statistical learning methods, artificial neural network, deep learning, specialized languages and hardware. Alan Turing wrote in 1950, "I propose to consider the question, can machines think?" He considered changing the question from whether a machine thinks to whether or not it is possible for machinery to show intelligent behavior. AI founder John McCarthy said, "Artificial intelligence is not, by definition, a simulation of human intelligence." Many researchers and analysts have argued that AI should simulate natural intelligence by studying psychology or neurobiology. Intelligence and agency. An intelligent agent is a system that perceives its environment and makes actions that maximize its chances of success. Any system that has goals and behavior in relation to those goals can be analyzed as an intelligent agent. This includes something as simple as a thermostat, as complex as a human being, large systems such as firms, biomes or nations. The intelligent agent definition provides a reliable and scientific way to test programs where researchers can directly compare or combine different approaches to isolated problems. They do this by asking which agent is superior at maximizing a specified goal. NEETs expect that intelligent behavior can be described using simple, elegant principles such as logic, optimization, or neural networks, where the scruffies expect and suppose that it necessarily requires solving a large number of unrelated problems. This was actively debated in the 1970s and 1980s, however in the 1990s mathematical methods and strong scientific standards became the norm. This was a transition that Russell and Norvig phrased, the victory of the NEETs. Soft computing is a set of techniques, including genetic algorithms, fuzzy logic and neural networks, that can be imprecise, uncertain with only partial truth and approximation. Soft computing was initiated in the late 1980s, with most flourishing AI programs in the 21st century being examples of soft computing added to neural networks. AI researchers are separated and split on the topic of chasing the goals of artificial general intelligence and superintelligence, AGI, immediately or to solve as many specific problems as possible, narrow AI. In our present time, narrow AI is said to be dominant, but by the 2050s it is predicted or estimated that an artificial general intelligence, AGI, or strong AI will emerge. In its basic form, AI researchers typically categorized AI into 3 levels. Level 1 is artificial narrow intelligence, ANI, higher up is level 2 artificial general intelligence, AGI, and level 3 is artificial superintelligence, ASI. If a machine has a mind, subjective experience and awareness, then it may also have sentience, which is the ability to feel, then it could also suffer, therefore it would be entitled to certain rights. The post-human critique at this point in relation to the previous statement is transparent in their critical post-human theory. Why should we allow the post-human AI to suffer or feel the same ways of our anthropocentric algostats or so-called pain receptors? Any hypothetical robot rights could be closely related to animal rights and human rights. This issue has been apparent in fiction for centuries, but it is being prematurely considered by the California's Institute for the Future. It's said that humanity's greatest robot, Asimov in Japan, has the mind of an insect, thus it's too premature to think about unalienable robot rights. Superintelligence. A superintelligence, hyperintelligence, or superhuman intelligence is a hypothetical agent that would possess intelligence far surpassing that of the intelligent human mind. Superintelligence may also refer to the form or degree of intelligence possessed by such an agent. If an AGI with sufficiently advanced programming existed, it might be able to reprogram and improve itself. It is stated that the improved software would be even better at improving itself, leading to recursive self-improvement, therefore its intelligence certainly might increase, exponentially, see exponential technology, in an intelligence explosion. Moreover, this AGI or ASI, artificial superintelligence, could greatly surpass humans in various aspects of learning, leading to a technological singularity. Science fiction writer Vernor Vinge named this scenario the singularity because it is like that of the event horizons of astronomical black holes, where we cannot see beyond this point. Because it is impossible to know the capabilities of superintelligent machines and limits of intelligence, the technological singularity is an event that is unpredictable, i.e. it is a black swan event. Robot designer Hans Moravec, cyberneticist Kevin Warwick, and inventor Ray Kurzweil have predicted that humans and machines will merge in the future toward cyborgs that are more capable and powerful. Edward Fredkin argues that artificial intelligence is the next stage in evolution. This is an idea first proposed by Samuel Butler's Darwin Among the Machines, as far back as 1863, and expanded upon by George Dyson, nonfiction author and historian of technology, in his book of the same name in 1998. The risks of superintelligence are as follows. 1. Technological unemployment. 2. Bad actors and weaponized AI. 3. Algorithmic bias. 4. Unfriendly AI, existential risk. To avoid these scenarios above, humanity must have good regulation of AI, create friendly AI, appropriately, and strategies to prevent a rogue cyborg or machine intelligence starts to act in ways that are detrimental to society. The technological singularity in science fiction. One curious fictional universe that exemplifies stages of AI, as I shall list later, is Orion's Arm fictional universe. Specifically, they focus on ontological sophons, ability to cognize, and singularity level progression, AI toposophic entity levels, trans-sapience, general futuristic concepts, theories and personalities. The links are in the description of this video. It essentially lists scales that measure specific toposophic AI's linear progress into greater intelligences. This includes, in no specific order, Forward scale, TRHM system, Barham 7 scale, Friendly baseline scale, the TBH Hyper-Turing scale, Sophon scale, the technological singularity models of linearity. The linearity of acceleration is basically moving towards ultra-ontologies that are beyond human numbers or words. This type of hard science fiction is somewhat realistic if we look at the grander scheme of things in the deep cosmic futures of our universe. Theoretically, by 10,000 AD, humanity or post-remnants of our Earth's civilization is said to become a type 2 or more in the Kardashev scale. The Kardashev scale essentially is measuring how much of our local stellar object's energy we can harness and use. After about 500 million years, our post-humans interstellar civilizations will reach a type 3 Kardashev scale into a galaxy-spanning civilization. If that wasn't mind-boggling enough, it is hypothesized that it could take another 10 billion years to reach a type 4 Kardashev scale. The most curious ideas relating to type 5 Kardashev scale civilization is the hypothesized years it could take to become a multiversal civilization, and it is in around 100 trillion years. Thus the artificial intelligence at the end of the universe, if one could call it that, could be the most powerful ontological entity ever known to exist. In relation to hard science fiction, in Orion's Arms lore, the most powerful being is at the sixth singularity, known as an archelect, or short for archai. An archelect in the geeky definitions of computing is hyper-Turing artificial being. The epistemic pursuit of all civilizations culminates in such a being's emergence after at least 5 centuries and beyond, according Orion's Arm website. Therefore an archelect is the ultimate AI, but in different levels of archelects, as described in science fiction lore and mythology. See my video Barrow Scale to learn more about the Kardashev scale. Science fiction is succinct in its transparency of dystopian outcomes of man's creation. The majority of films appear dystopian through our monolinear binary lenses. However, in some sense science fiction films are protopian, but it lacks extropian values. In hindsight, extropian values of posthumans in the 1980s would have created far more realistic films. The utopian goal, as we know, is not real in any sensibilities, because the word utopia actually translates to not a real place. There are various topias, or places, in the future, but this is to be outlined in my video A to Z Futurism, Dystopia. As an archive of all films from the 1930s, I am listing the various AI from year, title of films, country, and artificial intelligence names. 1987 CE. 1996 CE. 2005 CE. 2012 CE. 2015 CE. 2017 CE. 2019 CE. 2021 CE. 'Stages, types, traits of AI. 7 stages of AI are: 1. Rule-based systems. 2. Context awareness. 3. Domain-specific mastery. 4. Reasoning machines. 5. Artificial general intelligence. 6. Artificial superintelligence. 7. AI technological singularity. Types of AI: analytic, functional, interactive, text-based, visual-based, combination of some or all. The traits of AGI and ASI in future can be difficult to predict, but the AI might have specific traits, and the topics associated with those traits are allopoietic systems, autopotence, capable of motion and perception, continuous learning and improvement, data ingestion and data adaptation, decisions making on its own, forward-looking, high capacity to predict and adapt, intelligence amplification (IA), intelligent agent, metacognition, reactive, self-replication. Thanks for watching. Drop a like, comment and subscribe.